Welcome to the Unit 10 Section 2 video on scatter plots and fitting functions. Recall that a scatter plot shows two data sets as one set of ordered pairs. A trend line, or line of best fit, is a model for the data. We will use Desmos to create a scatter plot and trend line rather than by hand. So to find the line of best fit using Desmos, you're going to go to desmos.com and click on Graphing Calculator. Create a table by typing the word table into box 1. Input the data into the table, and then click the Zoom Fit button in the lower left-hand corner to scale the graph to the data. Then you're going to look at the data and determine which function best models the data. Then type in the box under the table the model you selected. Note the variables must match the column titles in the table. So here are the things that you will type in based on what the column titles are, x1 and y1. And you're going to use a tilde instead of a equal sign. But you'll type in your forms. A x1 plus k, or a is your slope, k is your your y-intercept, and then you've got your a, h, and k as normal in your quadratic and exponentials. So it will tell you what a, h, and k are when you type that in, and you can put those in the appropriate places of your equation using your forms. Now, I do want to note that this will work in Desmos, but newer versions of Desmos actually allow you to just select, do you want to use a linear, quadratic, or exponential fit? So let's take a look at an example. The following data represent approximate heights for a ball thrown by a shot putter as it travels x meters horizontally. So you're going to take this table of data and you're going to put it into Desmos, and you're going to figure out which model would best fit this data. And in this case, you're going to find that a quadratic best fits this data. Then you're going to write the function to represent the data, taking the values that are given to you by Desmos and rounding it to the nearest hundredths place if needed. So this is the equation that you would get. Your a is negative 0.01, your h is 47.72, and your k is 25.53. Using that equation, we're now going to determine what would the height of the ball be if it traveled 80 meters. So you're going to plug in the 80 into the equation we just found in B, and you're going to find that it's 13.961. And we're going to find out what an accurate prediction for the distance traveled would be. Well, the distance traveled would be when it hits the ground again. So in this case, y would be 0, and you will solve it for x and find that it's 95.675 meters. You can alternatively use the graph on Desmos and find what your value would be in the ordered pair at 80 meters for C and at the ground being 0 for D. So in this case, 80 meters would be your x value, so you're finding your y and c, and then your 0 would be your y value in D, so find what your x value that goes with it is. In this example, 10 students from Mrs. Jones' class reported the number of hours that they slept in the night before their test. Their corresponding test scores are reported below. So graph this data, find the model that would best fit the data, in this case it would be linear, and write a function to represent it using the values that Desmos gives you, and you will find it's 6.38x plus 35.63. So now, again, find on your graph, for those students who slept 10 hours, that would be your x value. Find the corresponding y value that goes with it. What would their test score be? And you would find about 99%. You can also plug in 10 for x in the equation that you just found using your calculator. For D, what would you predict a student who slept 3 hours would receive on the test? So again, plug in 3 for your x and find the value to be a 55. If a student received a 45, what would be an accurate prediction about the number of hours slept before the test? Now you're going to plug in 45 for y and find out what the corresponding x is. You can also find it on your graph and find it's about 1.47 hours. Recall, a correlation describes a relationship between two data sets. A graph may show the correlation between the data. The correlation can help you analyze trends and make predictions. There are three types of correlations between data. You have positive correlation, where both sets of data values increase. Negative correlation, where one set of data values increases as the other set decreases. And no correlation, where there is no relationship between the data sets. Determine the type of correlation, positive, negative, or no correlation, given a scatter plot. So A here, some of the data is going down, but some's going up. You can't make a definitive call on either, so there is no correlation. For B, the data all generally seems to be going up, so it's positive. And for C, the data all generally seems to be going down, so negative. Now we're going to determine the type of correlation given the real-world scenario. The height of a candle and the amount of time it stays lit. Well, as the time goes by, as time increases, the height of the candle decreases. So since those are opposing, we would have a negative correlation. The amount of rainfall on Fridays. Well, some Fridays it rains, some Fridays it doesn't rain. So there's really no correlation there. And the price of a pizza and the number of toppings added. As you increase the toppings on the pizza, the price of the pizza will go up. So that is a positive correlation. The correlation coefficient is a measure of how well a correlation of data points can be modeled by a trend line. Correlation coefficients range from -1 to +1. The closer the correlation coefficient is to -1 or +1, the less scattered the points are and the stronger the relationship. The closer that it is to 0, the more scattered the points are and the weaker the relationship. So you have perfect negative correlation from -1 and perfect positive correlation at +1, and you have absolutely no correlation when it is 0. The table here shows the total fat and the amount of calories in various fast food items. So we are going to put that into Desmos, and we are going to determine what our correlation is. And we are going to also look at what model would best fit the data. And the model that would best fit this data would be linear. The value of R, which would be given to you in Desmos, the correlation coefficient is 0.9706. And what it means is how closely the trend line fits, which means that we have a strong positive correlation. Determining the strength of the relationship between the total fat and the total amount of calories is a strong correlation. And the type, we're going to write a function to represent the relationship between the total fat and the total amount of calories. So you're going to use the values that Desmos gives you, and you get 10.33x plus 234.52. What is the predicted number of calories a hot dog that has 18 grams of total fat? You can plug that into the equation we just found. You can plug it in for x and get your y being 420.371 calories. Approximately what is the total fat in grams of a sandwich that has 350 total calories? Well, now we're going to plug in 350 for y, solve for x, and get 11.185 grams. Remember, in these real-world problems, make sure you include the units. Two people, Adam and Bianca, are competing to see who can save the most money in 1 month. Use the table and graph below to answer the following questions. So what we want to do is get this into a form where we can do a more direct comparison. So we're going to take Adam's savings and write the equation for this graph using our slope and our y-intercept. And then we're going to take the data in the table here, you can put it in Desmos if you would like, and find what the equation is for that. So Adam's equation is y equals 3x plus 3, and Bianca's is 3x plus 2. So we want to determine who will save the most money at the end of the month. Well, since Adam started with more money, and they're both saving money at the same rate, Adam will end up with more money at the end of the month. How much money does each person have at the start of the competition? Well, that's going to be our y-intercept. So Adam starts with $3 and Bianca starts with $2. Two small rockets were launched and their paths are modeled by the graph in the equation below. Use the information to answer the questions. So we have an equation already for B. Let's find an equation for A. Which rocket reaches a higher maximum height? What is the height? So to find the height for A, we are going to do negative B over 2A. First of all, for B, so rocket B has a height of 64. When we put our axis of symmetry in, we find it's at 2 seconds, and we plug that in and get 64 being the height in feet. So 64, we look at our graph, rocket A appears to reach nearly 260 feet, so rocket A at about 255 feet is the one that reaches the higher maximum height. Which rocket hits the ground first? How long does it take for the rocket to reach the ground? So again, we're going to look at rocket B. We have our axis of symmetry, which is 2. So that means that it's going to take another 2 seconds to complete the parabola. So it will reach the ground at 4 seconds. It will reach the ground first because rocket A takes 8 seconds to reach the ground if you look at the x-axis. Which rocket is higher after 6 seconds? And what is the height? Well, since rocket B is already back on the ground at 4 seconds, then we can already tell that rocket A is going to be higher at 190 feet. And we read that off of the graph. After graduation, you are offered 2 jobs. Cedar Grove Associates offered you to start you at $30,000 with a 6% increase per year. Maple Grove Associates provided you with a table to represent your salary for the first 10 years as shown below. Use the information given to answer the following questions. What type of function does Cedar Grove model? What type of function does Maple Grove model? So we take Cedar Grove Associates and we can tell that we have a starting value and we increase by 6% each year, so that would be an exponential model. If we look at the table of values for Maple Grove, we have a starting value of 40,000 and we add 200 each year. So that would be, or I should say 1,200 each year. So we have 1,200x plus the starting value of 38,800. Now the starting value here would be year 0. So we do have to subtract 1,200 from the 40,000 to get what our y-intercept would be to be able to model it with an equation. Now that we have equations, we can do a little bit more of an in-depth analysis of the comparison between the two. So after 5 years, at which job would you be making more money? What is that amount after 5 years? So we're going to plug in 5 for Cedar Grove and get that the value was $40,146.77. Also plug in 5 for Maple Grove and see that we will be earning $44,800. You can also read that off the table as well. So you would make more money at Maple Grove after 5 years, a salary of $44,800. Which company would be the better option to choose as a long-term career? So let's project this out 10 years. Cedar Grove, 10 years down the road, you'll be making $53,725.43. At Maple Grove, you can plug in the value. You can also read it off the table. You'll be making $50,800. So Cedar Grove would be a better long-term career choice since the salary would be more after 10 years and will continue to grow at a faster rate each of the following years since it is a percentage increase on what you're making the year before. So if you're looking for short-term work, you're going to work, say, 5 years, Maple Grove would be the way to go because you'll earn more money. But if you're looking for a long-term career of 10, 15, 20 years, you may want to go with Cedar Grove. Thanks for checking out my video in the Foundations in Algebra series. You can subscribe to my channel. I've got the next video queued up for you, and if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.